Will be course practice, chapter 5. So they tell us here that these three trucks, they have the equal masses, identical masses, and the tires are the same. فعشان the tires are the same, they're going to have the same surface area of contact. ف they want us to arrange the minimum pressure, maximum pressure, and medium pressure. So the maximum pressure is when the weight is distributed on a small surface area. So here it only has two wheels, so it's the maximum pressure. Here it has three wheels, and here it's four, so this one has less pressure than that one. So since this one has less pressure, it's medium, and then this one is minimum. This one has more pressure علشان there is less tires to distribute the weight. Here they said that a coin is in a liquid, and they want the direction of the pressure on its upper surface. So the surface in red. So we know that pressure is always normal to the surface, so since this is the pressure, it's going to be perpendicular and downwards. So vertically downwards. Again, force exerted due to pressure in a fluid, it's always normal. It's always normal. Now section 5.2. James has mass of 80 kilograms. When we're talking about pressure, you always convert to newtons. They gave you G is 10, so 800 newtons. For weight, W equals mg, m is 80, G is 10, so 800 newtons. And the area, he stands on 1 foot, and the area of his shoes is 200 centimeters squared. Again, we convert to meters squared, so we divide by 10,000. So it is 0.02, and pressure P is equal to F over area. So force is 800 divided by 0.02. You put it in your calculator, you get 40,000. And they want 40,000 pascals. They wanted scientific notation, so 4, you move it the decimal point 4 times, and it's 4 times 10 to the power 4 pascals. When a man stands on the floor with both feet, he exerts blank pressure than when he's standing on 1 foot. When he's standing on both feet, there is more surface area for the weight to be distributed on than when he's standing on one foot, so he exerts less pressure. This one you have to memorize. Pressure is measured using a pressure gauge, and liquid pressure is a U-tube manometer. They want the pressure in point A and the pressure in point B. They gave us the height is 3, cross-sectional area is 2, and the force is 5 newtons. So we know pressure in liquid is isotropic, and it's not acting on an object, it's acting on the walls, so it's going to be the same pressure all over the container. So we do pressure PA is equal to 5 to F over A area. Area they gave it to us in centimeter squared, so we convert it to meter squared. So it's 2 over 10,000. So F is 5 divided by 2 over 10,000. It's going to be 0.0002. You put it in your calculator. You get 25,000. And same thing for this one. P equals F over A. F is 5, A is 0.0002 equals to 25,000. They said they want the answer in kilopascals, so you divide by 1,000, 3 zeros cancels, and it's 25 kilopascals. Here they're asking for the rule of the pressure in liquids. Density, I don't remember the name of this thing, but density times G times H is the rule for this. The crush depth is the maximum depth a submarine can submerge without getting damaged. The crush depth of a Seawolf class submarine is about 730 meters. Density of water is 1200 and G is 10. So they want us to find the pressure that this thing can withhold. So pressure is density GH. Density is 1020 times G is 10 times height is 730. You put it in your calculator, 1020 times 10 times 730. You got 446,000. They want the answers in megapascals, so you divide by 1 million. And you get 7.446. They want three significant figures, so 7.44, or you round it up, so 7.45. They accept both answers here, but if it's in the written, you should put 7.45 because you round it up. They accept both. Here they're asking about the relation between depth and pressure. As depth increases, depth is the height, and then the rule density GH. As height increases, the whole thing is going to increase معها. So as depth increases, pressure increases. Here they said the area of a shoe's heel, of one of the shoe's heel, is 150 centimeter squared. The weight of the person wearing these shoes is 600 newtons. So P equals F over A. F is 600 newtons, and this area is for one heel, and since there are two heels in the shoes, it's 300 centimeters squared, and you want to convert to meters squared. So 300 divided by 10,000, and it's equal to 0.03. So 600 over 0.03. You put it in your calculator, you get 20,000. They want the answer for 10 to the power of 4. So 2 times 10 to the power of 4 pascals. Last question, a diver of mass 70 kilograms, 700 newtons, you multiply by G. They gave us G is 10. And the density of water is 1020. And the diver is 5 meters below, so pressure is density GH. Density is 1020 times G10 times H. H is 5. Here in this question, you don't even need the weight or the mass or whatever. You don't need it. So just act like it's not there. They put it there to confuse you. So 1020 times 10 times 5. You get 51,000. And they want kilopascals, so you divide by 1000. And it's 51 kilopascals. This is 5.3. For this question, they're asking about how a straw works. You have to memorize how it works. So the pressure inside the straw is smaller. Pressure inside the straw is smaller. It's not equal to the atmospheric pressure. Difference in pressure can causes the liquid to be pushed up with the straw, and if a hole is made, it will be impossible to drink through it. The pressure of the liquid inside the straw exceeds the atmospheric pressure is also wrong. This whole quiz is memorizing theoretical stuff. If a fluid is open to an atmosphere, you have a fluid here. The surface be acted upon by what is known as atmospheric pressure. There will be pressure from here, and this is ATM pressure, atmospheric pressure. A small object is immersed into liquid of density 1000 kilograms per meter cube. The object is 2 meters, density 1000, and G is 10, and atmospheric pressure 100 kilopascals, so 100,000 pascals. To find the pressure when the surface is open to atmospheric pressure, you get pressure equals density times G times H plus P ATM, atmospheric pressure, density is 1000, G is 10, and H is 2, plus PATM 100,000. You put it in your calculator, 1000 times 10 times 2 plus 100,000, you get 120,000. They want the answer in kilopascals, so you divide by 1000 and it's 120 kilopascals. This is how a plunger sticks. The plunger sticks to the surface of the floor under the influence of atmospheric pressure. It's atmospheric pressure, atmosphere pressure, or they also accept atmospheric, since the pressure outside the sucker is greater than that of inside. This is the last quiz in chapter 5.4. You should know this contraption or whatever it is, this instrument. Allahu A'lam what it is. It's called a barometer. You just have to memorize it, a barometer. And it measures atmospheric pressure, and the unit in the first ring, you can see it here, 760 for 1 millimeter. So it's literally in the answer is in the thing, so it's millimeter Hg in the outer rim, so millimeter Hg. If you remember in chemistry, we took that 760 millimeter Hg is 1 atmosphere, and it's up on top here, so it's 1, and millimeter, so it's millimeter Hg. They're asking for the name of the instrument. Here it is a U-tube manometer, and the ending is closed, so it's a closed end manometer. And then for part B, they're asking for the value of pressure. Whenever they tell you pressure, you work by this principle. Since it's on the same level, it's equal pressure. So they want the pressure of the gas here, and this whole height is 2.5 centimeters for this one and 2.5 centimeters for that one, so 5 centimeters. So we know the height is 5 centimeters. Again, they want the pressure of the gas here, so at this point, and points at the same level, they have equal pressure, so same point here, 5 centimeters. You convert into meters, and it's 0.05 divided by 100 meters. And the pressure of the gas, the density of mercury, always convert to SI units, so 13600. At this point, you should know the density of mercury. We had it so many times. At this point, you should just know it. Kilograms per meter cubed, and G is 10. And it's closed at the end, so no need to add atmospheric pressure at the end. Pressure equals density, GH. Density is 13600 times G10 times H, 0.05. You put it in your calculator, 13600 times 10 times 0.05. You get 6,800. They want the answer in kilopascals, so you divide by 1000, and you get 6.8 kilopascals. This one you have to understand it or memorize it. In any container, a liquid always forms a uniform level. In any container, the liquid is going to have a uniform level. You're not going to see a liquid going up like this. Use your common sense. In connected vessels, حتى if it's in a connected vessel, you can see it here, مثلا like this. The liquid is going to be here. It's not going to be going up like this or whatever. A liquid settles at the same level, irrespective to the size and shape of the vessel. It's size and shape. By pulling a syringe, a partial vacuum is created. The higher pressure outside, the syringe pushes the fluid inside, and the bicycle pump is a mechanical device that moves the fluid by pressure or suction. With this question, they're asking about the hydraulic press. So the rule for the hydraulic press is F1 over A1 for this one equals F2 over A2. So the instrument shown is a hydraulic press. Given the downward force, on the 20 centimeters squared. So this is the area is 20 centimeters. You don't have to convert when it's in hydraulic press علشان it's a ratio. The units cancel anyways. The force is 12 newtons, and the upward force on the other one is 36 newtons. So they want the area, they want A2. So F1 is 12 over A1 is 20. F2 is, we're gonna put it X, sorry. They gave it to us 36 newtons, and A2 we're gonna say X. Cross multiply, 12X equals 36 times 20. So X equals 36 times 20 over 12. You put it in your calculator, 36 times 20 divided by 12, and you get X equals 60. They said centimeter squared, and you didn't convert it in the beginning, so you no need to convert at the end. This one you have to memorize. An open-end manometer measures the difference between pressure of a gas and the atmospheric pressure. A closed end it's used to measure the absolute pressure of a gas. So in this question they want the height 2, height 1 is 15 centimeters, divide by 100 to get it in meters, 0.15. Pressure 30 kilopascals times 1000 to get 30,000 pascals. And the density 13.6 grams per centimeter cubed. We want it in meters cubed, so 13,600 meters kilograms per meters cubed. We use P equals density GH. H here is delta height, so H2 minus H1. Pressure 30,000 equals density 13,600 times 10 times H2x minus 0.15. 30,000 equals 136,000 x minus, you put it in your calculator, 20400. You move it to the other side, it becomes plus, you get 50400 equals 13600 x. And then you move 136,000 to the other side, you divide it, so 0.37 approximately يعني equals x. This is in meters, they want it in centimeters, so you multiply by 100 to get the answer in centimeters. Here the difference between mercury level in a manometer connected to a gas vessel is 12 centimeters. So this is the height, we convert it into meters, 0.12 divided by 100. Use 10 for G and 13,600 for density, and atmospheric pressure 100 kilopascals, multiply by 100 by 1000 to get the answer in pascals. For part A, pressure equals density GH. Here it is a closed-ended manometer, so forget about atmospheric pressure. Density 13,600 times 10 G times H 0.12. You put it in your calculator, 13600 times 10 times 0.12, you get 16,320. They want it to one decimal place and in kilopascals, you divide by 1000, you get 16.32. Again, one decimal place, so 16.3. Here they said 16, but they also accept 16.3. The answer asks for one decimal place, so 16.3 is the correct answer. Now B, it's an open end, so you add the atmospheric pressure at the end. P equals density GH 13600 for density times 10 G times 0.12 plus atmospheric pressure 100,000 equals. Now we already got this from the last part, 16,320 plus 100,000 you get 116,320. Again, one decimal place, kilopascals, divide by 1000, 116.32, so 116.3. Another hydraulic press question. Do you know the rule F1 over A1 equals F2 A2? They gave us this area is 4 centimeters squared and this area is 50. They want the force X. So F1 is 20 over A1 4 equals F2, we say X, over A2 50. Cross multiply 50 times 20 over 4 equals X. 50 times 20 is 1000. 1000 divided by 4, you get 250. So it's 4 newtons. This is all of chapter 5 for physics.